3, 2, 1. Boosters in ignition.
The Artemis 1 unmanned test mission has provided the first launch of the biggest operational rocket in the world, a lunar flyby, and a trip farther away from Earth than any other human-rated spacecraft, and along the way, some glorious images of the Moon and Earth. But now comes the critical part, the ultimate test of the Orion capsule, the primary objective. Will its heat shield protect it during re-entry into Earth's atmosphere? The full heat shield has never been tested, as it will be during this re-entry. That's because the spacecraft will be returning to Earth at an extremely fast speed, traveling nearly 25,000 miles per hour, or Mach 32. The heat generated will be 5,000 degrees Fahrenheit, about half as hot as the sun. NASA leaders have always pointed to this re-entry as the critical test for Orion. If the heat shield doesn't work, plans to return astronauts to the Moon could be dashed. Some might be a bit anxious, but not the deputy manager on the Orion heat shield. Jeremy Vanderkam, who's been working on this heat shield since 2006, says he's excited.
It's been a long time coming to finally get our first lunar flight test in.
This NASA, the executives all the way to the top say, is the most critical part of this mission. Why?
Well, there's a few reasons for that. First off is this is the first large ablative heat shield that anyone has attempted to use since the Apollo program for human spaceflight. And so a lot of the expertise, a lot of the technology that was developed for the Apollo program had since been lost, at least in this country, through the advent of the space shuttle program, et cetera. So we had to recover all of that and the ability to do that as a nation to really make that kind of heat shield technology work. Then this is the first time, the Artemis 1 mission is the first time that heat shield is being tested for what it was designed for, to come back from the Moon. Our flight test in 2014 did not go all the way to the Moon, so it gave us a good stepping stone to what we needed, but this is the first actual test of our technology.
The space shuttle had tiles on it, which basically protected it when it came back through the atmosphere. Ablated means it purposely burns off to dissipate the heat.
That's correct. Yeah. So materials like the space shuttle tiles are insulators. So they maintain their shape, they maintain their form, and they just insulate the vehicle against heat. Ablative systems actually burn up, if you will, on purpose, consuming a lot of that heat energy that is developed during reentry into an atmosphere. And that is required for missions that are so hot that we actually don't have insulative materials that can survive that kind of heating. We have to turn to ablative systems.
I mentioned that executives at NASA say the most critical part of this mission is reentry and this heat shield working, because without it, we're not sending astronauts back to the Moon. How difficult has it been? I mean, you've been working this problem for a long time. As an engineer, how tough was this to make this system that you expect to work?
I mean, we had a fair amount of challenges. One of the things that perhaps folks know about the Orion heat shield is that it's made out of blocks of material that are adhered with an adhesive onto the structure, and then there are seams in between these blocks. And we had to make it that way because of the size of Orion. It's 5 meters in diameter. And so developing this system, specifically one that has these blocks of ablative material for a lunar return class vehicle, is something that's never been done before. And so we had to work through all of the design engineering, put together a test program that proved that it'll work, and then figure out how to actually apply it in hardware to the system to get it ready to go for the flight test.
There is so much heat that's going to be generated on this reentry coming direct back from the Moon that you could not test this heat shield on the ground. You can't create 5,000 degrees of temperature to see how it performs, right?
Well, we actually can, but on very, very small test articles. So we're limited to those kinds of temperatures on pieces that are no more than the size of a hockey puck, 4 inches in diameter, say.
3, 2, 1.
West models in.
We can do that in what's called an ArcJet test facility. We have them at NASA Ames Research Center, which is where I work out of. But that's all we can do. So getting from 4 inches in diameter to 5 meters in diameter, that's the big extrapolation we have to make, and why we fly flight tests before we put crew on these vehicles.
Extrapolation, you use the word. You wouldn't be flying this if you weren't confident. How confident are you?
I'm very confident. We've been working on the policies that we use to design the system. The test program that we've put together for the system has over 1,000 tests behind it just for aerothermal performance. So yeah, I'm highly confident that it's going to work. I'm more excited than anything else to get it back and really show how good of a job we did.
Showtime for you is on the 26th day of this mission when this thing hits the atmosphere. What are you doing for the next 2+ weeks?
Well, so one of my roles on the program is actually to go out on the recovery ship with the recovery team and do the first inspections of the vehicle when it comes back to evaluate how our heat shield is done. And so we actually are going to go start doing the workups to that, the training work for the ship's crew for that in just another week here. So I'll be off with the Navy shortly, and we'll be working up to December 11th, splashdown day, from that time on.
There will be a blackout period. There always is a blackout period when a vehicle comes back through the atmosphere. When do you breathe a sigh of relief? When you hear some communications from it, you see the parachutes, the drogues, or the mains. When do you finally get to exhale?
For me, I actually have a very special opportunity to make that exhale being on the ship. We'll actually hear the sonic boom of that vehicle coming in after it's exited its blackout, and that'll be the first sort of de facto sign that yes, in fact, the heat shield has worked because the vehicle is there and intact to make a sonic boom. So I'm looking forward to that probably the most out of anything.
Just hearing the sonic boom, knowing that your shield worked and there's a vehicle coming back to the planet.
It's here, yeah.
There's a lot riding on your shoulders.
Yeah, there is. But at the same time, this is why I and why those of us on our team have come to NASA to do these things, right? To do these hard things, to be asked to put together these critical systems. And it's been such an honor, and it's been a lot of fun, despite the challenges to get to here, to have done that now and to be able to finally prove that we've done it together.
Everything works, and it splashes down nicely after 26 days. Is it a celebration? What is it?
Initially, yes, it's a celebration for sure. But we have a lot of work to do when the Orion crew module lands after Artemis 1. We go into a long period of looking at the data that we've taken off the vehicle. There's all kinds of instrumentation in that heat shield in space right now that'll be measuring temperatures during reentry. We'll be looking at that to see how well that those match up with our analytical computer models. We'll be harvesting the heat shield ablative material itself from the vehicle once we get it in our hands, and go and comparing how that material looks versus how it looked in our tests in the ArcJet facilities and how our models predicted it'll work. All of that gets rolled up to write the final certification for crew operations on Artemis 2. That's our final certification check mark, is the results of the Artemis 1 mission.
There is a chance you will learn something from this first mission that could actually change the way you put together heat shields for the follow-on Orion capsules?
Yeah, there's a chance of that. And actually, in some ways, that's a hope, right? We'd like to be able to show that after we get all the data back from Artemis 1, that we've actually designed the system so robustly that maybe we can expand the operating envelope of the follow-on missions, right? Maybe Artemis 2 can fly a little bit differently, or Artemis 3, 4, 5 can actually fly through more of a performance envelope than what we've designed them to because of what we learned on Artemis 1.
While Vanderkam and his team have done the hard thing, and he's confident and excited to see the heat shield perform, it's being part of the larger Artemis program and its goals that drive him.
One of the goals of the Artemis program in general is to return humans to the moon, and specifically to put the first person of color and the first woman on the moon. And that's something that really speaks strongly to me. I've gone through my life and my career with certain privileges because of who I am. And it's good to be a part of something that can elevate those who haven't had that same privilege in the past. So I'm really proud of that part of this.
Jeremy, best of luck come December 11th, when you get to see whether your life's work of the last decade plus works. I think everybody's pretty confident that you're going to nail it. So good luck, and thanks so much for sharing some of the work that went into this mission.
Sure thing. Thank you very much. My pleasure.
Vanderkam will be there on the ship as Orion is carefully recovered from the Pacific Ocean, the first to see how the heat shield looks. Did it protect? What lessons it carries? All to help put astronauts back on the moon. I'm David Curley. That's Full Throttle.